Hello, my name is Edgardo, and this is my final project, a Streamline music generation using Magenta and Luigi and turning it into a Pset. Overview. Automatic music generation is still to this day a great challenge. The latest advances in machine learning and deep learning have produced interesting results, but most of them are limited to monophonic music generation without sound dynamics. The musical nuances that makes the music more human, like accents, changes in volume and sustain, etc. Google Magenta is a research project from Google Brain in machine learning and deep learning for creating art and music. Magenta comprises several tools and TensorFlow models that are accessible through an open-source Python library. The newest performance RNN model from Magenta is aimed to a more natural polyphonic music generation, including dynamic expressions. Drawbacks. Unfortunately, the tools in Magenta's performance RNN module are aimed to be executed manually at the command prompt, using Bazel as a layer for calling the scripts. This makes the process of creating a dataset, training the model, evaluating the model, a manual batch processing of multiple stages. Good sounding music production is an iterative process, and it depends on the choice of the sample data as much as it depends on the hyperparameters. MIDI music files are used to feed the model. The process to prepare the data involves several steps for cleaning, formatting, data augmentation, and encoding before the model can be trained. Usually these kind of LSTM models require a long time of training, at least 2000 epochs. Proposed solution. I wonder if, using Luigi tasks, I can streamline the process to train and generate music. Using the Magenta performance RNN model, allowing easy dataset creation, model training, and music creation with a trained model, all within the same flow. Finally, use the lessons learned to create a problem set. Challenges. The documentation on the Magenta library is almost inexistent, and since the creation of the performance RNN is very recent, there are no other examples or sources of information. This is the process flow I created based on some of the tools from the Magenta library. The process starts with the decision of train a model or not. If we decide not to train the model, we can start generating music based on a pre-trained model. If we decide to train the model, then we start converting the MIDI files to notes sequences as a protobuffer. Then that protobuffer has to be transformed, augmented, one-hot encoded, and divided as a trained dataset and evaluation dataset to feed the model. During the model training, the DAG for the model is created, checkpoints, and metadata. Once the training is finished, we can save the model as a bundle, as a package. Or we can create music using the metadata that has been created. If we create a bundle with a new trained model, we can use it to generate music in the same way we did with a pre-trained model, but now with our newly created model bundle. These are the functions used in the process flow. This is the tasks dependencies graph. As you can see here, the first task needs as an input the sample MIDI files and then converts them to note sequences. As a TF record. This file serves as an input for this task to create the dataset. And this task also requires that the previous task has been completed. This task converts the protobuffer TF record and divided into test and train records, which are used later to train the model. Also, the task for training the model requires that the creation of the dataset has been completed and the information is ready to be used. During the training, this task creates the model metadata. This model metadata is used to generate a new model bundle or to create new music. This task to generate the bundle requires that the training has been completed. But also, as you can see in the graphic, this task can be used by itself without the requirement of a previous task. But it requires that a pre-trained model bundle is used as an input or the new bundle we just created in order to create new music MIDI files. This is a music sample created with this flow. The problem set. Once this flow was completed and correct, in order to reduce the complexity, I fixed most of the parameters with acceptable values, and then I turned my project flow into a Pset. This new Pset starts by creating music using a pre-trained model, and then expands the Luigi flow to a full model production flow, including the data wrangling, the training of the model, the creation of a model package, and the use of a new model package to produce music. This is the Pset repository, and these are the instructions. It starts with the setup, how to render the repo, what is required to be installed, the Magenta tools that had to be acquired, and it starts with the part of the process for generating music with a pre-trained model, using two tasks, one external task and one external program task. It also applies the concept of atomic writing. And after that, it extends the process to the full flow. For so far we have done this part, and this is the second part for creating the training and packaging of the model. So this is the part on training your own model. Here explains how to get sample data. How to convert, this is the first task, to convert the MIDI files to note sequences. An external program task to create the train and evaluation data sets. And finally the training of the model. And how to generate the model bundle, which actually is done with the same task, applying some conditions and changing the target outputs. And the process that will run. And finally, generating music using the bundle created previously. And all this is just to glue all the parts, applying the conditions for the decisions within the process flow, like train yes or no, create a bundle, and generate music. And this is the end of my presentation, and thank you very much.